guys, you're welcome to my channel wherever you may be watching this from, be it Twitter or YouTube or the like. So I would like to briefly explain the machine learning structure that is powering the talking stage application I created. So this is a machine learning network that is based on the decision tree network, and it's being powered by lightGBM, which is light gradient boosting machine that uses a stepwise growth strategy rather than the depth-wise growth strategy that is peculiar to most decision trees. So looking at all this, these are all the nodes of this decision tree network, and the lines are the connections that contain the rules for splitting at every node they are originating from. So this is a text and this is the label. The text is what the user types into the talking stage application, and the label is what the machine learning actually outputs as a prediction. So let's look at it one by one. Once you send a text to this machine, it passes through this first node. Yes, it passes through this first node that normalizes it, that sends out, it takes the text and sends it out to the text normalizer. This is a text normalizer over here. The text normalizer takes input from what we just left now and then outputs it to the next node, which is meant to tokenize the text. It does the tokenized text transformation, and then once this tokenization has occurred, the tokenization of the text, remember that the text is just a string of multiple words, so these multiple words needs to be broken down into their individual words. This is what this tokenization is all about. So it gets sent out to this connection and then enters into this node. These nodes here contains all the possible tokens that the machine learning is expected, which is what you are seeing here under the attributes, the term map, which is what you are seeing here. You can see inputs from the text word tokenizer, and then it outputs it through the word extractor. That is, you then extract words from these tokens. That's what happens. It extracts words from the tokens and sends it to the next node, which is the 001. Now this 001 does the n-gram transformation. N-gram just means the number of words per token. If it is 1 gram, means 1 word per token. If it's 2 gram, means 2 words per token. If it's 3 gram, means 3 words per token. And this is how it's being mapped. And then it outputs it again to a text word extractor from it. You can see that, which is then sent to this transform 005 node. Now in this text word extractor is the one that actually takes the feature from this 001 and sends it to 005. So in 005 it already has some features in it at this point. That's some features in it at this point at 005. 005 then splits up into two different places. This is the splitting of it. The ones that goes to this concats, the one that goes into the select column transform reaches a terminal node, and the one that splits into this 006 transform then becomes a text, then converted to a text again, and then the text goes into this 001, this concat transform 001. The concat transform 001 provides the feature that is used for predicting the label eventually, for predicting the y, which is the which is the dependent variable. So it outputs the features again. It outputs the feature again and sends it to 003. Now this 003 is not only taking features from 001, it's also taking a term called label from 002. Label is the actual prediction, the actual thing that the model is going to predict. So it needs to take that label, and it also needs to take the feature. Then the combination of these two things is what 003 would use to calculate and make a prediction, which is being outputted as a feature also. So this 003 actually contains the lightGBM mechanism. It's the one that actually predicts, that does most of the prediction. So you can see all these parameters, all these numbers that you are seeing, they are the weight. They are the weight of all the features that are being collected from 001. And it also contains the schema. The schema is what talks about the name, the type, the size, the offset, and different things, the metadata and the rest of the collections of all the features and labels. So it combines those two things and puts out a feature, which we then, in the code behind, which will then be converted back to a label, being in a text format that our talking stage application would use to output to the user. So this whole connection is what makes this talking stage quite intelligent. So there are lots of mathematical calculations that is going on in the background. There's a lot of splitting that is happening in different nodes in order to determine if one or two features are present and how relevant it is. This is how the talking stage intelligently determines what the user is actually asking for and what it actually means. So you can see that a lot is actually going on in the background. And in future explanation, I'm going to use a better visualization technique. So this is just a 2D visualization of the model. In future, I'll try to use a 3D visualization so you can actually see it work. You actually see it in 3D in a more beautiful way than what you are seeing here. I'll probably use this tensorspace if it supports the model from ml.net, and see if we can visualize and explain it in a more beautiful form. I didn't want to really go too deep into it and explain all the mathematics that is involved for people who are not so who do not really like maths that much. I will have gone into it, but that will be a video for another day. And all of these are actually found in folders. If you notice that this is actually having comma, like now this particular one is within a transformer chain folder that is inside a transform, actually is within a transform 00 folder that is inside a transform 002 folder that is inside a chain folder that is inside a transform 000 folder that is inside a transformer chain folder. So these are just multiple folders within folders in the model file itself. I just wanted you to take note of that. So it's not the traditional ONNX format that you would expect for a model. This is just the way the ml.net model is structured, and I hope you enjoyed this. So there are lots of transformations. Now let me talk about this 004. So this 004 is the one that takes the features from 003 that we just talked about now. The 003 is the one that does the actual prediction, right? And then it sends it to 004. Yes, it sends the feature to 004 that then converts it to the original label. So I made a mistake in the last statement. 003 doesn't actually convert the feature to the label. It's 004 that converts it to the label that our talking stage application is going to understand using the key to value transform. Exactly. The key is what the model understands, is what the model uses in making calculations, uses this in indexing, in identifying the individual features and the rest. But the value is what our application is actually going to understand. So it needs to convert the key back to its value and then be outputted to the user to actually see the prediction. So I hope you really enjoyed this explanation. I'll see you again in the next video to provide more in-depth explanation of everything. Thank you.